Welcome to video 2 on section 4.3, and realize that how can we use the vertex and axis of symmetry to determine, or what good is it? And so that's where we are coming up to, and in particular, here we go. Example number 7, we are asked to graph the function using its vertex, the axis of symmetry, and the intercept. So we will have a slight bit of remembering how to find intercepts, but that won't take long either because that is review from a little bit earlier. But we have f of x is equal to x squared minus 6x plus 9. Now the first thing we have to do is to find the vertex. Well, the vertex, if we remember, is negative b over 2a. And we notice that this ends up equaling 6 over 2, or 3. So h is equal to 3, and then to find k, we get f of 3, which is 3 squared minus 6 times 3, plus 9, which equals 9 minus 18 plus 9, which equals 0. And so our actual vertex would be 3, 0. The axis of symmetry, as always, is x equals 3. And then as far as intercepts are concerned, we need to find the two types. First one is find when x equals 0. F of 0 is 0 squared minus 6 times 0 plus 9, which equals 9. And so the intercept will occur, one intercept will occur at 0, 9. That's an easy one. And then the other place that we need to be concerned with or want to deal with are when we want to set this equal to 0. So we get x squared minus 6x plus 9, set that equal to 0, and it becomes x minus 3, the quantity squared, because this is a perfect square trinomial. And so x minus 3 equals 0, or x equals 3 would be the intercept. And of course, as it turned out, we actually happened to determine that somewhat accidentally. But now we're actually ready to graph it. And so what we get is we know at the point 3, 0, there is the vertex. The axis of symmetry is x equals 3, so we can just draw that, and it's going to reflect around that. It's going to be symmetrical about that. We know at 0, 9 there's an intercept over here, so, and one way to look at it, since it reflects, we know over here there's going to be another point, and then what we can do is we know this whole thing is going to be a parabola, and so we get this very poorly drawn parabola, but I think you get the idea that that's what we need to look for. We need to look for the vertex. The axis of symmetry we're going to use because we know it reflects on both sides, and then once we get a few intercepts, we get a few other points, and then we can graph a relatively accurate graph. So here we go with example number 8. Example number 8 is f of x equals negative x squared plus 6x minus 5. So right off the bat, let's see, h we can determine is negative b over 2a, which is negative 6 over negative 2, or 3. K would then be f of 3, which is negative 3 squared plus 6 times 3 minus 5, which equals negative 9 plus 18 minus 5, which equals 4. So our vertex will be 3, 4. The axis of symmetry is x equals 3. I can find a pretty quick intercept. F of 0 would equal -5. Just plugging it in here and all the x's become zeros. So I know one intercept is 0, -5. And even more so, set this equal to 0. If I set this equal to 0, I want to get rid of the x squared, or the negative, I'm sorry. So I'm going to change all of the signs. Set that equal to 0 and let's solve. So let's see, this would become x minus 5 and x minus 1. So that means x would equal 5 or x would equal 1 when I set each one of these equal to 0. So I have a whole bunch of information, so I should be able to graph this relatively easily. Start out. The vertex occurs at 3, 4. The axis of symmetry is x equals 3. I have an intercept at 0, -5. And I know for a fact that that will be reflected over the axis of symmetry, so that really helps there. I have intercepts at 5, 0 and 1, 0. So I've got those points. Now it becomes relatively simple to draw a fairly decent looking parabola. And there we go. This would be -x squared plus 6x minus 5. So that's how we can use this particular information without having to use the transformations, which doesn't require us to remember any of the points. It just requires us to get a few new points. Examples 9 and 10. Determine the domain and the range. Well, the domain is relatively simple because we look at, is there any time that we need, I apologize for this delay. Are there any values that we can't plug in for x? That's what the domain means. And if we look at 9, there's not a single value that we can't plug in. We can plug in zeros, positives, negatives, integers, fractions, decimals, radicals. We can plug in any value whatsoever. So number 9, the domain would be all real numbers, which we show from -infinity to infinity. But then the range. The range, remember, is what values do we end up with? And what we want to attempt here is to figure out, okay, what is the absolute smallest value, or what is the absolute biggest value that we can get here? And so what we do is we're actually going to use h and k h, of course, we remember is negative b over 2a, and this will equal 2. K will equal f of 2, which equals 2 squared minus 8 plus 4, or 4 minus 8 is -4, -4 plus 4 is 0. And so we know our vertex is 2, 0. Now once we know that, then we should be able to determine our range. Because we have 2, 0, we know is either going to be the smallest value or the biggest value, because that is the vertex. So what we look at is, which one is it? Is it the minimum or is it the maximum? And here all we need to look at is the original equation. And we look at A. If this is positive, then our vertex is always a minimum. If this is negative, then our vertex is always a positive. And the range is always dealing with the y values. So we know 0 in this case would be a minimum. So that means the range, we can get the value of 0, but that's going to be the absolute smallest we can ever get. And so the range would go from